Alright, we're going to start Chapter 15 today, which focuses on second derivatives. Our learning targets for this lesson are the first two are review from Chapters 6 and 7. So we're going to remind ourselves how to find the first and second derivative. And then using that first derivative, we're going to find the maxima and or minima of a function. New to us today is the point of inflection. So we're going to use the second derivative to find that point, and then we're going to determine using that point of inflection where the graph concaves up and concaves down. And finally, our ultimate goal is to sketch the graph of f of x using information gathered from f prime of x and f double prime of x, as well as the roots of f of x. So let's get started with some curve sketching. So this is called curve sketching because we're going to be plotting accurate critical points. That would be like the roots, the maxima, minima, if there are both. And we're going to be accurately sketching the directionality of the graph, but not everything's going to be completely accurate, hence the word sketch. So it's going to have some very accurate features and some features that would be considered a sketch. So let's get started. So let's look at this function, f of x equals x to the fourth minus 4x cubed. So the first thing we want to do is we're going to factor this so we can find the roots. So if we look at both terms, x to the fourth and negative 4x cubed, we should notice that both terms share x cubed. So I'm going to factor that out front. What's left inside the parentheses is x minus 4. So if I wanted to ensure that I'm doing this correctly, like double check that I didn't make a mistake when I was factoring, I could say x cubed times x, that gives me my first term, x to the fourth, and x cubed times negative 4, which gives us the second term, negative 4x cubed. So that's factored correctly. So by definition, a root occurs when we set f of x equal to 0. So we're going to do that for each part of our factored expression. So 0 equals x cubed and 0 equals x minus 4. We're going to solve for x. So the first thing I'm going to notice here is that 0 equals x cubed. That means we're going to have a triple root at 0. Okay, and then we also see that we have a root at positive 4. What this means is whenever we put 0 in for x or 4 in for x, our whole equation is equal to 0. So we're just going to start a little chart here to show that we have roots at 0 and 4. So this is the number line of f of x. Alright, let's move on to find the derivative of f of x. So, finding the derivative, we have f prime of x, and that equals 4x cubed minus 12x. So let's go ahead and factor out what's common in these, and if we look, oops, I dropped the squared off of this, what's common is 4x squared. When we factor that out, in the parentheses we have left x minus 3. So, since we're trying to find the maximum or minima from the first derivative, we know that the maximum or minima occurs when the gradient or slope is equal to 0. So we're going to go ahead and substitute 0 in for f prime of x. We're going to set each factor equal to 0. So here we end up with 0 equals x and x equals 3. Okay. So I'm going to go ahead, and this is going to be 0 and 4 again, and then I'm just going to put 3 in here. So these are our two roots, and not our roots, these are our two x-coordinates for maxima and minima, potentially maxima and minima. We're not quite sure until we see how the increasing and decreasing factors work. So let's go ahead and do that, and then we'll find the y-coordinates of these in just a moment. So basically, from 0 to negative infinity, we need to figure out if our function is increasing or decreasing. So let's pick a value like negative 1, because that's an easy number to deal with, and we're going to substitute negative 1 into the f prime equation. So everywhere I see x, I'm going to pop in negative 1, and I'm going to see if my result is positive or if it is, oops, I'm writing the wrong equation, half right, half wrong. Minus 12 times negative 1 squared. Okay, So when I do this, I get negative 4 minus 12, because negative 1 squared is positive 1 times negative 12 is negative 12. So that's negative 16. So that means all my values to this side from 0 to infinity are going to be negative. Okay, we're going to do the same thing between 0 and 3. So between 0 and 3, what we're going to see, I'm going to use positive 1 here. We're going to see if it's increasing or decreasing. So again, 4 times 1 cubed minus 12, I'm substituting 1 for x squared, we end up with 4 minus 12, and we end up with still another negative number, negative 8. So this is all negative here. Get rid of this work. Okay, so what this means is that since the directionality is not changing, the negative values for x mean that our graph is decreasing, it hits 0, and it still decreases. That means that 0 is not a minimum or a maximum. So it's neither. Alright, so let's see if on the other side of 3 we have a minima or maxima. So 3, let's pick a number greater than 3, so let's do number 5. So we're going to say f prime of 5, and everywhere I see x, I'm going to put in like that. Okay, so I end up with 4 times 125 minus 12 times 25, and that gives me positive 200. So that means that everything, remember, it means that we're increasing. Okay, so everything to the right of 3 is going to be positive values on the derivative. So our graph is going to be increasing from 3 to positive infinity. Alright, so since we know 0 is not a maximum or minimum, we don't need to do anything with this. But let's go ahead and find the coordinate of the maximum or minimum. We're not sure. Well, we actually are sure. We're going from negative to positive, so we know that this is going to be a minimum. So let's go ahead and find that coordinate. So I'm going to go ahead and plug 3 into my original equation to find that y coordinate. So f of 3 is equal to 3 to the 4th minus 4 times 3 to the 3rd. So we have 81 minus 4 times 27, and that equals 81 minus 4 times 27, negative 27. Running out of room, so I'm just going to write across here. So the coordinate of our minimum is 3, negative 27. Okay, alright. So let's talk about what a point of inflection is, and then we'll go ahead and find that using the second derivative. So basically, it's the point at which a function's concavity changes. So basically, its curve is changing direction. So how do we find a point of inflection? Well, we're going to take the second derivative, set it equal to 0, and solve for x. So if we have upward concavity, we're going to see that our curve is going to look something like this. That means that the second derivative is going to be greater than 0. Downward concavity would look something like this. Okay? And that means that our second derivative is less than 0. If our second derivative equals 0, there is no point of inflection. So let's go ahead and try to find it on this function. By the way, 0, 0, it's a point on the graph, it's just not a maximum or minimum, so that doesn't really need to be there. So let's go ahead and find the second derivative here. So we have 12x squared minus 24x. So let's factor this out because we need to set it equal to 0 and solve for x. So it's going to be helpful if we factor it. So 12x, we have x left, minus 2. Alright, so we end up with 0 equals 12x. and also 0 equals